Welcome. Welcome to today's presentation. It is regarding the image and photography. So, what do you mean by image? And what did you mean by photography? And what is the difference between these two? So this is the this is the uh, objective of today's presentation. Now, before going to the in detail about image and photography, let us observe this picture to have an idea about different types of remote sensing. As you can see, when you are observing a ground from at the same level, you are working as a remote sensing camera because you are observing the ground remotely from your eyes. Same thing can be done by a crane lifted camera. This is a crane lifted camera. And also a camera fixed at the belly of the airplane. It also captured image remotely. High altitude planes and its camera fixed in its belly also captures these images from a remotely placed location because this plane is placed at far away from the field, and it is observing the field by a camera fixed in the belly of the plane, whether it is high altitude, all low altitude, or satellite. This is under the Earth's atmosphere, but satellite roam or rotate in the out of space. So when satellites use their cameras to capture the images above the Earth's surface, it is satellite-based remote sensing. So this is the basic difference between various stages of remote sensing. Certainly, the most accurate images is captured when you are observing the field by your own eyes, but the span of capture will be very limited. This span will increase with the height at which the camera is placed. So, in case of remote sensing, you can understand the span of observation and distance from which observations being made or captured. These two is very important for remote sensing, remotely sensed images. So, and also accuracy of the images is also an important thing. How accurately the camera has captured the image. This is also very important. So that is why when you are observing from ground, you are observing this image minutely, but your span of observation is very limited. But when you are lifting a camera in the crane, the span increases, but accuracy decreases. And in similar manner, span of observation will go on increasing when the distance of the remotely placed camera is increased from the area of interest. That means from this area of interest is the area being captured by the camera placed in different lines. Now, what is the basic difference between image and photography is? The image and difference between the image and photography is when image when something is captured by a camera, be it digital camera or photography, it is referred as photography. But whenever any visual object is captured and then modified and saved in a computer system or some recording tape, then it becomes an image. So photograph is a raw image of a feature, and when this feature is stored in the computer system after being modified or after being altered, that becomes image. And remember, whenever an image is stored in a computer, it is modified a little bit automatically to adjust the spectral and spatial resolution of the image. This is basically the very basic difference between image and photography. Whereas image is a photograph which has been modified or altered by a computer system and stored in the system, and uh, photograph is a image which is being digitally captured by a camera or remotely sensed camera or digital camera or photocopier. Some instrument has captured that image, but it has not been altered. Then it becomes photograph. So photograph is actually raw image captured by the camera. Now this must be remotely placed camera. That is why it is not sensitive, right? But whenever this photograph is altered or modified, both are same. This became image. This image is recorded in a film of the hard drive of your computers. Somewhere it is recorded. So let us move into the next slide, and you see another basic difference has been raised. What is the difference between pixel and digital number? Basically, pixel is directly proportional to digital number and is directly proportional to brightness or darkness. No, I would say it is directly proportional to brightness only, and that means it is directly proportional to reflectance. So more the what is the pixel value, more will be the dm, more will be the brightness, and more will be the reflectance. So now in case of digital number of a panchromatic image, that means a single band image, that means either it is black or white. There the numbered lesser digital number or less pixel value uh, is darker, and higher pixel value is white. So basically this is black and this is white. This white indicates that whatever light has been incident on the surface that is being captured by the camera, the entire light spectrum is reflected back to atmosphere. That is why it is white. Whenever this reflectance get reduced because of lots of disturbances like noises, clouds, etc. this reflectance, when it gets reduced, it makes the image from gray to black, correct? And this, when gray is converted to white, the reflectance is increasing in that area. Correct. So basically, and for this is for black and white, that is panchromatic imagery, which is a single band image only, which stores the different values of the this black color. But the thing is that when it is in multispectral, then let us say this is your panchromatic and this is your multichromatic or multispectral. So panchromatic has a single band of black color. Here nothing is being reflected, so it should have been black. But here everything is being reflected. So this will be white. So everything reflected means whatever light has been emitted on the earth surface, it is being reflected. Now if it is a light source or light ray, then it is okay. If it is an auditory signal, then we have to adjust the computers accordingly. But basically it is light-based system. So this light is from sun, it gets incident on the earth surface and it reflected back. But if it is absorbed by the earth surface, due to some speciality, uh, then some amount of this light will be absorbed by the earth surface. So it will not be a total reflectance. But whenever the highest reflectance is achieved from the surface, it was observed that the color of that surface become white in the captured images. So now this is okay. So that is all about panchromatic. Similarly, for panchromatic, this is only the black and white. Light coming and reflecting. Total reflection means white. Complete no reflection means black. And in between you find gray, dark gray, deep gray, and lighter gray, lighter gray. So, and for multispectral image or multichromatic image, similar band of red color, blue color, and green color will show different characteristics. This is a wavelength versus transmission graph, and this is the whatever light gets incident in the surface and it gets reflected back. Due to this refraction, different wavelength is formed, and within this wavelength, the wavelength which is nearly 0.4 to 0.7 nanometer, sorry, microns, that is your visible light. So, and this is reflected infrared means reflection, large amount of light is being refracted, and it has gone into the infrared area. That means more than red. Thermal infrared is more higher reflection wavelength, and far infrared is of course very higher wavelength or in case of this far infrared also. So these are all higher placed, but this is also the lower place. That means the absorption is minimum in this case, whereas absorption is maximum in these cases. Right? So let us go. And the same characteristic is maintained by the red band, blue band, and green band with different intensity it creates 24 number of bands. So the higher the value of the bands, lighter is the color, and lower the value of the bands, darker is the color. Now, what is the difference between spectral and spatial resolution? I was discussing about these two topics just few slides before. Now, the spectral resolution is the bandwidth. It is actually the bandwidth as shown in figure 1. You will see this is the bandwidth, and this is your visible light. Sorry, this is your visible light. This is also known as which you can remember when after when sunlight is there, generally rainbow takes place due to the reflectance or refraction of the sunlight while coming into the earth first. But for now, this is the situation. This is this very small bandwidth from 0.4 to 0.7 is maintained by this is maintained, and whatever light being reflected and achieve a frequency wavelength of 400 to 700 nanometers, it comes under the visual. So this is what the spectral resolution is. Means more the band, more will be the spectral width. So lesser number of band means less will be the spectral width. Mainly spectral resolution means the bandwidth of a certain wavelength. Okay. So basically what happens is the spectral resolution, if we say that this is a higher spectral resolution, it implies that more than one band is available in the image. When the spatial resolution is changed, so what is spatial resolution first of all? This is the spectral resolution, this is bandwidth. More the bandwidth, more will be the spectral resolution. But here, pixel comes into play for spatial resolution, and the pixel can capture a 10 square kilometer area, or also it can capture 10 square meter of area. So the definition is like that: spatial resolution of raster because the area of the ground that being covered by one pixel. Okay. So you can understand that area which can be covered by each pixel. So this is the difference between saying what is bandwidth. More the bandwidth, more is the spectral resolution. Another one is the area encompassed by the company or by the pixel, sorry, not the company. More the area, lesser will be the pixel number of pixels within the specific area. Suppose this one, if I say that this has the area, this is 5, so 5 meter by 5 meter. So around 25 square meters the area is the image area, of which 1 meter by 1 meter is captured by the one pixel. But however, if there is an image where 1 pixel covers 100 meter by 100 meter, then it is a pixel. Okay. So So this is what the spectral resolution is. I am again saying with the one band high spectral resolution, more area captured by single pixel, more area captured by single pixel, higher spatial resolution will be observed. Okay. So this is what we expect. Now, what is the spectral reflectance curve for the vegetation? Spectral reflectance curve means this is reflectance and this is your time, then your spectral reflectance will not get initiated at all. Okay. But if it gets initiated and if it shows like variation like this, then these graphs must be delivered to like some section of these graphs may be delivered to delivered to us such that you can understand the spectral signature of each of the feature. To a little bit, okay, there is a when blue and gold is absorbed and during the photosynthesis, during the pigments, and that is why leaf is green because blue and red has been transformed, and uh, that is why you can see as blue and red is absorbed during photosynthesis. That is why each of the leaves of a tree looks highly red during the photosynthesis. So, and during the data collection and during the procedure, this being delayed out. But however, if you can see this green is reflected back also 10 to 15% from incident image. In case of leaf, at a time its photosynthesis is being produced. So this is what it is, and uh, what happened is that when we take a image of a map, so this is basically what I want to say is that there is red, blue, and green color in each of the images captured by different camera based on its characteristic. If it is mono or panchromatic, then it has only single band. But you have multi faceted family. So when there is mono, there is spectral reflectance from one band. When there is this two color image, then spectral reflectance carries three bands, sometimes four bands. The fourth band is actually the infrared. Here, this is a graphical image showing how the light is being reflected and encoded by a remotely sensed camera. So, this is the spectral reflectance curve with this wavelength, and if we take just the visual wavelength, we can see the reflectance of deciduous, grass, aquatic, coniferous, near infrared, red, green, blue. So for each band, you see different types of reflectances. So, for green, this is this reflectance of green So this is actually the used to be the green color. So, so this is what you can understand, that when the leaf is green, that means it is reflecting out the green part. Correct. So this you must remember. Here you will just next one, next spend, and in case of spectral reflectance of soil, how light is reflected after falling into soil. So this reflectance factor of soil is influenced by the moisture content of the soil, texture, surface roughness, presence of iron oxide and organic content. Now if there is moisture, then reflectance will decrease. And similar absorption characteristic for clay soil. Clay soils have iron, hydroxyl iron, and soil moisture content is strongly related to the soil texture. For example, all these things are. So this is spectral reflectance from water. In the previous slide we have spectral reflectance in soil. Now it is coming water. So in case of this, along with reflection and transmission and absorption, diffraction may also take place. And as you know, water can be of three forms. One is solid phase, that is ice, another is gaseous phase, and another is liquid phase. So if it is in the solid phase, then high dm number will be assigned. If you are the liquid, the medium dm number, and for the last one, you can, the last one, you can see that, you will see that how the dm number behave for the other points. So more or less, the spectral reflectance from water is solid, good reflection, liquid, medium reflection, sometimes fluid, and this gaseous has also good reflectance. So now you see reflectance from the water body. There is this is being described, and as you can see, water surface material suspended in water. This is nothing but total suspended solid, and so according to the reflectance of light, different properties of water can be adjusted. So this is what reflectance of water is. Then the various different scenarios. If it is clear order, the short order, then transmittance, that's so the target TV and transmitter. So this is clean water, shorter wavelength, less than 0.6. Then transmitter, these are different types of transmitters reflectance being observed for different types of water, clear water, and water where algae is present, water where large quantities of suspended sediment is present. This type of water the body is receives a very high reflectance. This is overall what is the reflectance from water. So overall concentration is also there. It also reflects light. It reflects the green light and absorbs the blue and red. So as I am saying, tends to decrease the reflectance in blue wavelength, increase the reflectance in green wavelength. So none are varying each other. So this is the reflectance from chlorophyll, because of chlorophyll concentration. So spectral reflectors of some natural features I have already discussed. So I have discussed about soil, moisture, water. So and different way the incident ray behaves after falling into the soil, moisture, or water. So in case of water, the different forms also have different reflectance. Ice, gas, ice, gas, sherbet, sometimes sherbet. So, so water, ice, gas, and there is ice means solid phase, gas means gaseous phase, and liquid means solid. So this is what is, and it has also shown us how the light is being reflected by chlorophyll concentration, not only in your green plant light, but everywhere. So each of the light, sunlight, when it gets reflected from the surface, depending on the characteristic of the surface, this value changes. So, so these are different spectral curve, how light behaves after falling into fresh snow, broadleaf vegetation, stressed vegetation, dry soil, turbid water, clear water. So in case of turbid water, what is happening? Easily says you see just beyond the visual wavelength. This is visual wavelength 0.4 to 0.7. Just beyond this visual wavelength, this reflectance drop like a, and in 1 micrometer it becomes dark. This is your turbid water. Similarly, if you were watching fresh snow after within the visual band, this is the visual band 0.4 to 0.7. So within the visual band, this the reflectance of sun is coming heavily. So that is why the reflectance is maximum within the visible length. And then broadleaf vegetation, yes, it gets prevented. Reflectance is prevented. Sometimes it goes lesser, sometimes it goes higher. Okay, so here this schematic diagram gives the wavelength divisions. So as you can see, 0.4 nanomicron to 0.7 nanomicron. This is the visible, and this will give you the another visible project. So this is the range of I 0.4 to 0.7, and beyond 0.7, I cannot see them, but to observe those, you need a spatial electron microscope and then observe what is being happening in it. Okay. So now lots of discussion with spectral resolution. We came to spatial resolution. As I have already said, the area covered by one single pixel. So, and there can be pure and mixed pixel in an image. Pure pixel is that only one kind of geographical feature can be encountered by this type of pixel. However, when different types of geographical feature is encountered in single pixel, then it becomes mixed. So both the area encompassed by the pixel, greater spatial resolution will be received. So I already discussed about this pure pixel. This is a one kind of feature, and there is a different kind of feature in one pixel. Okay. So, and as usual, more the number of mixed pixels, now, what is exposure? This exposure determines that how bright or how dark is your picture after being captured. So this is actually the amount of light per unit area reaching a photographic film or photographic image sense as determined by shutter speed. So this exposure is measured in lux seconds, and it can be computed from the exposure value and single units. But by definition, photography means exposure. And it is indicated, it is represented by the amount of light per unit area. So this becomes the photo index or so, and next one is gamma exposure. So this is a schematic diagram of a camera and the image being captured. This is the image being captured and this is the camera. And this one is diameter T. With the time T, very short time the shutter is open and closed. This is the object. So this is your lens and this is an image. So we have very simple term for determining the focal point or focus of the camera. So this is this 1 equal to 1 by 0 plus 1 by 1. Okay, so f is actually chota f is actually the lens focal length, and O is objective distance and image distance also. So this is the basic formula for determining the focal point of a camera. 1 by f is equal to 0 plus 1, right? So this is the way to calculate exposure. E is equals to S. This S is actually the scene brightness in joules per millimeter square per second. Scene brightness is D is the diameter of the lens, T is the exposure time, that means how much amount of time the lens was opened, and then this is the focal length, F. So it seems that exposure is directly proportional to scene brightness and distance or diameter of lens opening and the exposure time, and it is not directly proportional with the focal length. So this is the f-stop or aperture setting, and this is going to the focal length divided by diameter length. So f is, that means f-stop is inversely proportional with diameter of the lens, and directly proportional with this focal length. So more the focal length, more will be the aperture settings or f-stop. So here it is saying that it is giving a very simple problem. A camera with focal length of 40 millimeter. So it's saying that it is producing properly exposed images with a lens opening diameter D of 5 millimeter and exposure time E, sorry, not E, it will be T, 1 by 125 seconds. If the lens opening time is increased by 10 meter, 5 meter to 10 meter, and the scene brightness does not change, then what exposure time could be used to maintain proper exposure? Very, very easy. So here you know what is the focal length, you know what is the diameter, you know you do not know what is the scene brightness is, and the thing is it does not change. Scene brightness does not change. They are saying so. This both this S1 S2 is deducted. T1 is given. T1 and T2 is given, which is 1 by 125 of 125 second, right? And then you calculate to find the exposure, and so first we have to find the exposure, and then you have to reverse it and find out the exposure time. Correct? Just put down the values. You see this 40 meter focal length, right? Focal length as 40. S1 scene brightness doesn't change in any cases. D is the diameter, it will not also change, and T will change a little bit. So it's saying that final one is 5 millimeter, 2 is 10. So similarly, you just put and find out the C1, exposure 1, as well as exposure 2. So to maintain the same exposure, these two exposure must be same. E1 is equal to E2. So then it all the cancel out, and ultimately it will give you the condition at which the two exposure can maintain each other.